Yes, good afternoon, Nushi. Please ask the others to come in very fast. I hope those who all are coming in are of BA specializations. I hope those who are coming in are all BA specializations. I will wait for about 2 minutes more for all the others to join. Please join in fast, class. Am I clearly audible and visible? Am I clearly audible and visible? There are only 7 students now. I would request the remaining 4 or 5 students to please join fast. Okay, so I think we should start. There's no point in waiting further. Today, the session will be a very important session because we will talk about multivariate analysis. The chapter itself is a complicated chapter because it has got the techniques that we're going to study today are factor analysis, multiple regression, and discriminant analysis. These are the 3 things we will study today, and that's all will be your multivariate analysis. Now, all these 3 things are quite complicated to understand if you are not focusing properly. If you are focusing properly, if your basic statistics concepts are clear, you will not be able to you will not face any problem. But I will try to make it as simple as possible with the basic concepts given because this is just an overview. You do not have to go into very depth of the analysis because these are all computer based, all software based. All right. So let us start with multiple regression first. Multiple regression. Since you have done regression in your earlier semester, you will be able to understand multiple regression a lot easier. What was regression? Regression was a term coined by Pascal. He tried to experiment with seeds. I'll explain the process, how regression came into being. He tried to explain or to experiment the hereditary pattern of seeds. Now, what kind of hereditary pattern was he trying to explain? He was trying that whether two large seeds or two small seeds, too large or too small seeds, when they go after generations, whether the large seeds gives rise to more large seeds or small seeds gives rise to more small seeds. He found that no matter what is the size of the seed initially, over generations, the size regressed back to its mean size. The size regressed back to its mean size. From here, the term regression was coined in. After that, the experiment was also done on human beings. The result was same. Parents with very short height or parents with very tall height, over generations, it was found that their children, their generations, regressed back to the average at human height at the adult stage. So this is how the term regression coined in. Now later on, as time progressed, regression became the method that became so popular in statistics that it became the backbone of statistics. What is regression basically? It is a model. Try to understand very carefully. It is a model that has got one independent variable and several dependent variables. One independent variable called y and several independent variables called x. Right? In the earlier semester, you had learnt about simple regression with one variable. That was y is equal to a plus b1x. That's it. Only one independent variable, one dependent variable. But now we are dealing with multiple regressions. In multiple regressions, we will have one dependent variable. Dependent variable can never be more than one, remember. In no statistical analysis, there's hardly one or two analysis available where there are more than one dependent variable. But in most statistical analysis, you will never have more than one dependent variable. Whereas there can be several independent variables. Now, whenever we talk about regression of several independent variables, x1, x2, x3, x4, and so on, we call it multiple regression. But multiple linear regression. Our subject only focuses on multiple linear regression. Non-linear regression is not within the scope of the syllabus. What is non-linear regression? Non-linear regression is that where one variable, one independent variable, say x3, is connected with y in a non-linear fashion. Maybe in an exponential fashion, maybe in a logarithmic fashion, whatever fashion, but not a linear fashion, not a straight line. A straight line is not the dependencies of the two variables. But in linear regression, we always assume all the variables are linearly dependent with the dependent variable, linearly related with the dependent variable. Is it clear? This much you have to understand first. So, I repeat once again, multiple regression is a model where there is only one dependent variable, one dependent variable, and multiple independent variables, which are also called exploratory variables. Ankit Vishwas is saying once more. Okay, I'm going to just speak once more. There is one dependent variable, y, and there are multiple independent variables x1, x2, x3, x4 up to xn. Now each independent variable has a coefficient. I've given you a page. I've given you this page where I've written about multiple regression. And in this page, I have told you that there are coefficients of independent variables b1 x1, b2 x2, b3 x3. What are these b's? These are coefficients of the independent variables. These coefficients are also called slopes. In the initial classes of learning while you're learning functions, you have learned about what is a slope. So slope or the coefficient gives the importance of the variable. Higher coefficient negative or positive. Higher coefficient negative or positive means the variable is more important. A coefficient which is very less, that means the variable is less important. Less important means the variable impacts the independent variable less. If you bring out that it has got a higher influence on the dependent variable y. There is also a term called a, the constant. The constant always remains in regression equation. Here is the difference between statistics and mathematics. In mathematics, we have got just y is equal to fx. There is no confusion about errors. We know what is the model. It starts from the paper, goes on to the field. But in statistics, it starts from the field, comes to the paper. And when it starts from the field and comes to the paper, you can never expect that everything will be exactly you want the way it is. It should be. There will be fluctuations. So you cannot expect that no matter how many variables you take in, you have completed the list. Say, for example, GDP is your dependent variable. What all influences GDP? You can talk about the per capita income as one variable. You can talk about the population as another variable. You can talk about the government policy as another variable. You can keep on talking about different factors, which is the y-intercept. The constant means the y-intercept. That is, if you draw a line where it gets cut at the y-axis, that is the y-intercept. Now, in multiple regression, we will not talk about lines, we will talk about planes or hyperplanes, planes of higher dimensions. That is multiple regression. Now, till this, is it clear? More or less. More or less, is it clear till this much? I just want 2 or 3 yes or no, whatever it is. Okay, to Abhi, it is still not very clear. So I would just explain it again in a simpler form, perhaps. Regression is a model that has got two types of variables. One is a dependent variable, the other is an independent variable. Dependent variable can be only one, independent variable can be many, as much as you want. X1, x2, x3, x4 up to xn. Each independent variable has got a coefficient b1, b2, b3, b4 up to bn. What does the coefficient mean? The coefficient means how important or how much is the impact of that particular independent variable. And what does the constant mean? The constant mean the y-intercept. That if you draw the plane of the hyperplane, where the plane cuts the y-axis. This is the regression, multiple regression model. Now is it clear? Can I proceed further? Okay. Now, in multiple regression, or multiple regression is basically used to solve causal statistical problems. It is a causal model. There are three types of models in statistics, or three types of researches in statistics. One is exploratory, one is descriptive, the other is causal. You have perhaps learned in your marketing research class that what are these three types of researches. Yes, no. I want yes or no. Exploratory, descriptive, causal. Have you learned it? Yes, no. If you have not learned it, I will explain. If you have learned it, I will not explain. Okay, you are saying yes, sir, we have. So what is a causal model? Causal model means it gives out, or it sends, or it brings up a cause and effect relationship between the variables, between the independent variables and the dependent variable. Okay, you need not write anymore yes sir, just listen. No need to write yes sir anymore, just listen from now onwards. In causal model, what it focuses on, it focuses on building a relationship, a cause and effect relationship between the dependent variable and the independent variable. A causal model is the highest form of research. So regression is one of the highest or the most sophisticated technique of any statistical research. Regression gives you the idea that which variable affects the dependent variable more, which affects less. And accordingly, we can take care or research further on those independent variables. We can carry on further research. So regression is so very important, multiple regression. In SPSS, how do you get into multiple regression? Multiple regressions normally are not done using manual methods, because in manual methods you have to again develop normal equations as you had done in your previous linear regression. Normal equations, if there are 10 variables, there will be 10 normal equations, because there will be 10 unknowns. Now, to solve with 10 normal equations, it becomes very difficult in ordinary least square method. So manually, multiple regression is not really solved. Multiple regression is solved through software. And we are talking about SPSS here, demonstration of SPSS. That is, we first go into the menu bar, we click on Analyze, there we click on Curve Fitting. In curve fitting, there is regression. While you click on regression, you will find there are two boxes. There are two boxes available. One box is the dependent variable box. The other box is the independent variable box. So whichever variable you want to make it dependent, click on the variable and shift it to the dependent variable box. Whichever variables are the independent variables, select all and shift to the independent variable blocks. Then you can run the regression analysis. Now, I could have stopped here, but one very important thing about multiple regression, which is not there in case of single regression, is multicollinearity. Multicollinearity. What is it? Multicollinearity is relationships or interrelationships between the independent variables. What we had talked about earlier, try to understand very, very carefully. What we had talked about earlier. Earlier, we had talked about relationship between the dependent variable and the independent variables. The dependent variable and the independent variables. Now we are talking about the dependent variable, now we are talking about the independent variable and the independent variable. Maybe two independent variables are interrelated. They have got their own interrelations. Okay, so if this is the case, then what happens is, say x1 and x2 has got interrelations. X1 influences y, x2 also influences y. See, I'll explain to you. X1 influences y. Is it visible? X1 influences y. X2 also influences y. X2 also influences y. Fine, I have no problem with it. This is the case of multiple regression. But if x2 also influences x1, if x2 also influences x1, then the influence of x1 on y will be increased, because x2 is influencing y directly once and x2 is influencing y indirectly once. So x2 is influencing y twice. So this is the problem with multicollinearity. If there is intercorrelations between variables, the independent variables, some amount of multicollinearity always exists. You cannot avoid it. But too much of multicollinearity means you are deviating from the original regression equation. You are not exactly finding the regression equation that you are required to find. So you have to test for multicollinearity diagnostics. If the value is very high, then you have to remove that variable which is causing the disturbance, or change the variable which is causing the disturbance. This is multicollinearity. So basically, this is regression equation. Now, in the paper that I have given you, the snapshot that I had given you, I have written something called y hat. Y hat. This y hat is the predicted value of y. There are two values of y, remember. One value of y you are collecting from the field, and one value of y you are predicting from the values of x. So there are two values of y. One value of y, again I am telling you, one value of y you are collecting from the field. The entire columns you are making. Y, x, 1, x2, x3, x4. You are making the columns from the field. And when you develop the regression equation, you are developing y hat. That is the predicted value of y. Now it is not necessary that y and y hat will be the same. They can be different. And this difference is the error. The error term in regression is the difference. When we are talking about least square method, ordinary least square method, we have to minimize the sum of this total error, total squared error. We have to minimize the sum of this total squared error. That is our motive, to draw the hyperplane of multiple regression. Okay, so this much concept you need to know about multiple regression. And I would request, if you can have SPSS at your home, or if you can download, or if you can install, please study the regression using SPSS properly. Or if you have a book which contains multiple regression, you can study that book properly also. I have already suggested a book in the class which has multiple regression, that is Lynn, Marshall, and Wathan. You can study that book and understand what is multiple regression properly. Okay. Next, the next topic. Okay, is the basics of multiple regression clear to all of you? I want 2 or 3 yes, or no, whatever. 2 or 3 yes. The basics, just the basics of multiple regression. See, the video that I am presenting to you now is getting recorded. It will have live stream, plus it will have a permanent stream. Okay, it will have a live stream, it will have a permanent stream. I will give you the link to the permanent stream also, or the link that you have used now. Even after 2 days or 3 days or 2 weeks, no matter what time, if you want to review this entire lecture, you can click on the same link, you will get the entire lecture. But you will not have the conversation with me that is you are having right now. That conversation will not be available, but the lecture will be available. So if you feel that you have not understood a single some part of it, you can just review the lecture later on. Okay, this is multiple regression. Next, we move on to discriminant analysis. Before we move on, again, I want to ask you a question. In your marketing research class, in your specialization class of marketing research, have you learned about the various measurement scales like nominal scale, ordinal scale, interval scale, and ratio scale? Have you learned about it? Nominal scale, ordinal scale, interval scale, ratio scale. Have you learned about it? Okay, you did. Stop here. Don't waste time in writing anymore. Now listen. Regression equation. See, semantic scale is something different. I'm talking about 4 levels of scale: nominal scale, ordinal scale, interval scale, ratio scale. I will just explain in just a minute. Nominal scale is that scale or that type of measurements or that type of numbers which has got no numerical value, like your roll numbers. Roll number 4 need not be better than roll number 2 just because 4 is higher than 2. This is nominal scale. Ordinal scale is orders, ranks. Rank 1 is how much ahead of rank 2, you don't know, but it is ahead. 2 is how much ahead of rank 3, you don't know, but it is ahead. So the order matters, but the difference we cannot understand. But in interval and ratio scale, the difference matters. Regression equation can only be done on interval or ratio scales. On nominal and ordinal scale, interval regression, multiple regression cannot be conducted. Discriminant analysis is another tool, which is a causal tool of research, causal research tool, where the dependent variable itself is of nominal scale. The dependent variable itself is of nominal scale. Where it is used, how it is used. Discriminant analysis is used to predict whether a future response, a future record will fall in which group, group 1, group 2, group 3, or what. Now, how is it calculated? It is calculated based on past records. I'll just give you one small example, it will be clear. Say for example, bank loans. When the manager gives loan to a particular person, or gives credit card to a particular person, or gives credit limit to a particular person, the bank will have to understand whether this person has got the potentiality. Understand very, very clearly. Sir, please repeat the last part. Okay, I am repeating the last part, but please understand the utility of discriminant analysis very carefully. You will understand the last part. Urshi will understand the last part. Please understand what I'm explaining right now. See, bank has got plenty of records, thousands and thousands of records of previous loans. And they have got also records that out of those loans given, how many have repaid, how many have not repaid. Bank has also got the records that what are the attributes of those people, those who have repaid, what are the attributes of those people, those who have not repaid or forfeited the loan. Now, using this past record, the manager can develop a model, a predictive model. Remember, the bank can develop a predictive model through which it is possible to understand that when a manager is giving loan to a particular person, or a particular person is asking for a loan from the bank will collect that particular person's information regarding his salary, regarding his work experience, regarding the stability, regarding the number of family members. Many attributes the bank manager will have information about. Number of dependents, or any existing loan, or his or her credit score. All records the bank manager will have. Now, based on those records, the bank manager will develop a predictive model whether this person is going to pay back the loan or this person is going to forfeit the loan. Say, for example, 1 denotes will pay back, 2 denotes will not pay back. Now, this 1 and 2 are nominal scaled variables. They have got no numerical significance. They are just used for coding. So this 1 and 2 are just nominal variables the bank manager will use. They are also called grouping variables. In discriminant analysis, they are also called grouping variables. Now, while giving loan, the bank manager will put in the attributes in the equation, discriminant equation, and find out whether the score is closer to 1 or closer to 2. If it is closer to 1, suppose there is only 2 variables, then the discriminant equation will create a line, a discriminant line. Now, the people, those who fall on one side of the line, say this is my line, and above this line are those people who have paid back the loan, and below this line are those who have not paid back the loan. So if a future respondent comes, a future person comes to ask for a loan, then if that person's attributes combination makes the person's discriminant score falls above the line, the bank manager will give him the loan. But if the discriminant score falls below the line, the bank manager will not give him the loan. This is the basics of discriminant analysis. So how it is done? It is done from, again, the menu bar, go to analyze, go to discriminant, and discriminant you will find something called grouping variable, and something called independent variables. Now in discriminant analysis, the advantage is you can have the independent variables of any type of scale. You can have nominal scale independent variable, ordinal scale independent variable, interval scale independent variable, ratio scale independent variable. You can have age as an independent variable, you can have income as an independent variable, you can have your gender as an independent variable, you can have number of family members as an independent variable, you can have anything as your independent variable. Okay, I'll just give one more example. Say, for example, preference of a car. Now, when a particular person is coming into a car showroom, the person who is dealing with that person will take down his information. Now, after taking down his information, the person who is interacting with the customer may like to know that in what kind of car the person's preference is, whether it is small car or big car. Accordingly, he will explain or give him models or suggest him small cars. Accordingly, he will suggest him big cars. Unnecessary time wasting is going to stop. So these are certain examples of discriminant analysis. Discriminant means what? It is to discriminate between two things, two or more things. Plenty of discriminations again is not very good. Two groups or three groups is okay, but more than that is not really desirable. Okay, so this is the basic understanding or fundamental of discriminant analysis. Is it clear? Now give me 2 or 3 responses. Just you need to understand the fundamental. Now, there is a book called Marketing Research or Research Methodology of Berry. Research Methodology of Berry, written by Berry. In that book, you will get discriminant analysis in details. Now we move on to the last topic called factor analysis. What is factor analysis? Along with factor analysis, I will also just give you a small hint about what is cluster analysis. Factor analysis is when you find or when you see that there are too many variables that you have to work with. When you are doing an exploratory study, as you have said that in your marketing research class, you have studied what is exploratory research, what is descriptive, what is causal. As regression, multiple regression, and discriminant were causal research tools, factor analysis and cluster analysis are exploratory research tools. Tools where research is just beginning. You do not know how many variables you have to work with. In most cases, plenty of variables comes into picture. I will give you an example. Which airline a person prefers to choose while traveling? Which airline? Is it Jet Airline? Is it Indigo Airline? What airline? Is it Indian Airlines? What airline? Why does that person prefer to choose one airline over the other? This is the question. Now, there can be several answers to it. There can be hundreds of answers to it of why he chooses one airline over the other. Why do you go to a particular restaurant without going to the other one? If two restaurants are side by side, if you go to a restaurant, you will go to this particular restaurant, not this restaurant. Why do you do so? There can be plenty of reasons because of which you will do so. Maybe the ambience of the restaurant is good, maybe the food is good, maybe the service quality is good, maybe the light is good, maybe the music is good, maybe anything is possible. There can be so many